Hello everyone. In this lecture, we are going to discuss about compiler and its phases. A compiler is a program that reads a program written in one language, that is the source language, and translates it into an equivalent program in another language, that is the target language. So source language means the program written in high-level language like C, C++, Java, etc. And target language means it's a assembly program. Okay, so we all know that a computer can understand only zeros and ones, machine language, right? So the humans has to give all the instructions in zeros and ones. In earlier days, they did like that. Okay, but it is a tedious task. So nowadays we are writing programs by using high level languages like C, C++, Java, Python, etc. But it cannot be understood by the computer, so that we need some language translator system. So compiler is one of the language translators. It will convert the high level language program into assembly program, that then the assembler will convert assembly program into zeros and ones, machine language. Okay, and it reports the compiler reports to its user the presence of errors in the source program. Okay, so compiler means it will convert high level language into low level language, the assembly language program, and it also reports the presence of errors in the source program to the user. So compiler will need 6 phases for converting the source program into target program. Okay, so compiler operates in phases. There are 6 phases. The phases are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. Along with these 6 phases, it needs 2 more modules called um, symbol table manager and error handler. The symbol table manager and error handlers are attached with all the 6 phases of the compiler. Okay. Symbol table is a data structure. It is like a table. So it contains records for each identifier with fields for the attributes of the identifier. It means, suppose the source program contains some identifiers like uh, X, Y, Z, etc. means, then in symbol table, the records will be created for each identifier. Okay. For example, consider the first record for identifier X. So it stores X identifier, and it contains fields for the attributes. Attributes means information about the identifier. For example, if X is in floating point variable, means we have to sorry, the in symbol table, the type information will be stored, and then the memory space occupied will be stored. So all the informations about identifiers will be stored. Then X, then Y, Z, all will be stored into the symbol table. Okay, so symbol table is a data structure. It contains record for each identifier with fields for the attributes of the identifier. Then error handler is attached with all the phases of the compiler, because compilers will intimate the error also to the user. So sometimes the program uh, may contain some syntax errors, semantic errors, logical errors, etc. So that will be identified by the corresponding phases, and it will be intimated to the user. Now we can see all the phases one by one. The first phase is lexical analyzer phase. So lexical analyzer phase will read the source program character by character and groups them into tokens. Okay, so the input for the compiler is a source program. It can be written in any high level language. So for example, consider we have a statement like x equals y plus z star 30, means it reads the program, the source code character by character. So first character is x, that will be converted into token. There are different types of tokens. So the tokens may be identifier, keyword or symbol, punctuation symbols, operators, or constants. Okay, so for example, we will consider one statement and we will see the output of each and every phase of the compiler. Okay. Okay, consider this example, x equal to y plus z star 60. Okay, so this is the source statement given as input to the lexical analyzer. Actually, we will give the entire source program to the compiler, lexical analyzer. But for the simplicity, we have taken a small one line example, one single statement. Okay, so x equal to y plus z star 60. Okay, we know that lexical analyzer will read the source program character by character and groups them into tokens. Okay, so this is given as input to the lexical analyzer. So the output of the lexical analyzer is uh, x. First it reads x. X is an identifier, right? So it will generate identifier as a token. For our understanding, in this statement, we have three identifiers. So to distinguish all the identifiers, we will consider ID1 for x, ID2 for y, ID3 for z. Okay, so ID1. Then equals is an operator. So directly we will write equals. Then y, this is also an identifier, so ID2. Then uh, arithmetic plus. Then Z. Z is also an identifier, so ID3. Then multiplication operator. Then 30 is a constant. Okay, so in this example, we have operators, identifiers, and constant also. Okay, suppose if we have a while statement or for statement, we may have keyword also as a token. Then punctuation symbol, if you use a for loop, now we will write for open parenthesis, etc., right, in C program. So we will write like this. So in this example, the open parenthesis will be considered as a uh, symbol. Okay, then this output, this is the token stream. Okay, so lexical analyzer will convert the source code into source program into token stream that will be given as input to the next phase of the compiler. Next phase is syntax analyzer phase. Okay. So syntax analyzer means it creates syntax tree. Okay, it will check the source program for any syntax errors. Okay, if the source program is containing any syntax error, it will be intimated by the syntax analyzer phase. So it checks the grammar rules of the language, whether it is correctly formed or not. Okay, so it will do so by using top down parsing method and bottom up parsing method. We will discuss the top down and bottom up parsing in forthcoming lectures. Okay, so here it will create a syntax tree. No, in that tree, interior nodes will represent operators and leaves will contain operands. Okay, so this is the input for the syntax analyzer. Okay, lexical analyzer's input, lexical analyzer's output will be the input for the syntax analyzer. Syntax analyzer will generate the syntax tree or parse tree. Okay, so first, in this statement, multiplication operator has higher precedence than addition, and assignment operator will have the lowest precedence. Okay, so first, the multiplication operator, the subtree will be created for the multiplication operator. So the operator will be in the interior node, right, and operands will be on the leaves. So star is the interior node, its left child will be ID3, right child will be 30, right? So ID3 is left child of star, 30 will be the right child. Okay, then addition will be performed. Okay, so plus symbol. So plus is the root, ID2 will be the left child, and this entire subtree, this will be the right child. Okay, so plus is the root right now, its left child is ID2, and right subtree is star. So star will be the root. Okay, so this is the expression first we have constructed. So that will be the right child for plus, left child will be this ID2. Okay, next assignment operation will be done. So the root will be assignment operator. For this assignment operator, left child will be ID1 and right subtree will be this entire sub expression. Okay, subtree, this entire subtree. So this is the syntax tree will be created by the syntax analyzer. Next phase is semantic analyzer. Okay, semantic analyzer means it will check the meaning of the language. From the name itself, we can understand, right? Syntax analyzer means it will check the syntax tree. Okay, so suppose if the program, the statement doesn't follow any syntax, means we can't construct the syntax tree properly. In that case, it will intimate syntax error appeared in the source program to the user. Okay, so semantic analyzer now it will check the meaning of the language. Okay, sometimes the statement may follow the program, may follow the syntax, but it won't follow the semantic meaning. Okay, for example, if you try to add two variables like a and b, suppose if you are performing x equals a plus b, but a is a name of an array and b is a name of identifier of the function call. Okay, a is an array identifier, b is a function identifier. Now we cannot add like this, right? But it doesn't affect the structure rule. Structurally it is correct, syntax is correct, but semantic is not correct. Okay, and mainly it is used for checking type. Okay, type checking. So in this example, assume that all the variables x, y, z or the floating point data type or real data type, but 30 is an integer. Means here type checking will be done by the semantic analyzer. Okay, so 30 is a floating point. 30 should be converted into floating point, right? Then only it can be multiplied properly with the ID3, and then other operations will also be performed. Okay, so semantic analyzer will do this by using into real operation in Pascal programming language. Okay, so first into real will be performed. Okay, into real 30. This is an unary operator. So into real is an unary operator. So it has only one child. Okay. Otherwise, we will have like this. Then this 30. Now the 30 will be converted into 30.0. Okay. Now this will be multiplied with ID3. So star is a root right now. Then the right child will be this subtree. Left child is ID3. Okay. Then similar to this uh, uh, syntax tree, plus is a next operator, that is ID2 will be the left child and this entire subtree will be the right child. Okay, so here also we have to do the same. So plus is a root, right child will be the subtree, left child is ID2. Then this will be again assigned to ID1. Okay, so here also we have to do equal to ID1. Okay, so here type checking is done and into real operation is performed. Okay, so the next phase is intermediate code generation phase. Okay, so third phase is semantic analyzer phase. After type checking, intermediate code generation will be performed. Intermediate code generator means it will produce the intermediate code for the source code. Okay, so source code cannot be directly converted into target code. It will be converted into intermediate code, okay, by with the help of intermediate code generator phase. So this is called as three address code. Okay, three address code means it contains sequence of instructions, and each of the instructions will have at most three operands. Therefore, it is called as three address code. Okay, maximum of three addresses. Each three address instruction has maximum of three operands. Okay. So the three address code for the syntax tree. Semantic analyzer's output is also a syntax tree only, but semantically verified. Okay, it checks the type also. So now, first into real of 30 will be performed. Here, intermediate code or three address code will generate temporary names for storing the intermediate results. Okay, so first we need to do into real 30. So to store that temporary names, we need to store that temporary result, we need some temporary variables. So first one is temp1. Temp1 is equal to into real within parenthesis 30. Okay. So into real 30 means the integer 30 will be converted into real 30, and that will be stored into temporary variable 1, first temporary variable. Next, multiplication will be performed. So id3 star id3 star this into real, this will this is already calculated and stored in temp1. So id3 star temp1 is calculated, and that will be stored into temp2. Okay, then next operation is this plus addition. So id2 plus this entire result. So this is already stored in temp2, right? So equal to id2 plus temp2, and that will be stored into another temporary variable temp3. Okay, then assignment. Okay, id1 is equal to the entire result. The entire result is stored into id1. So id1 is equal to temp3. Okay, so this is performed by the intermediate code generator. Actually, these instructions are called three address instructions because it contains a maximum of three operands. Okay, if you see the second and third instruction, you can see the three addresses or three operands, right? So here in the second instruction, temp2, id3, temp1. These are the three instructions. In the third instruction also, temp3, id2, and temp2 are the three addresses or three instructions. Three operands. Okay, and it may also have fewer than three operands. For example, in the first and second, we have only two operands. Okay, and all the three address instructions will have at most one operator in addition to the assignment operator. Okay, for example, here into real is an operator, here multiplication star, here plus. Okay, and here there is no operator, so at most one operator in addition to the assignment operator. So this is the output of the intermediate code generator. Next one is code optimizer. Code optimizer means it attempts to improve the intermediate code. Okay, so it may reduce the number of lines, number of instructions, or sometimes it may replace multiplication by addition. For example, if you need to do yeah, x square, okay, or x star x, x star x. Sorry, if you need to perform x square, exponent operator can be replaced by x star x, right? Similarly, if you need to do 2x, 2 into x means multiplication can be replaced by addition like x plus x. Okay, so This is strength reduction. Okay, so these kind of improvisation can be will be performed by the code optimizer, so that faster running machine code will result. Okay, so number of lines of code may be reduced, or many code optimizations are available, that we will discuss it in the coming lectures. Okay, so now the in our example we will see the code optimization output. So in the first statement, temp1 equal to into real 30. Into real operation is used for converting the integer 30 into real 30. Okay. So instead of this, we can simply substitute 30.0. Okay. So in that case, we can remove or we can eliminate temporary 1. Okay. So first, we can directly do the second multiplication. Okay. So we need first temporary here. So temp1 equal to ID3 star temp1. Temp1 contains into real 30, right? So that can be directly substituted like 30.0. Okay. Code optimizer will directly do like this. Then ID2 plus temp2 is stored into temp3. Again, the temp3 will be assigned to ID1. Okay. So we can avoid temp3. We can eliminate temp3 by directly substituting ID1 here, right? So ID1 equals ID2 plus temp. Here it is 2. Okay. But here we have substituted temp1. So temp1. Okay. So now 4 lines are reduced to 2 lines. Okay. This optimization is performed by code optimization phase. Then the last phase of compiler is code generation phase. So it will produce the target code or assembly code. So now the code generator phase will produce the target assembly code. So first we have to construct mnemonic instructions, right? Assembly languages can be written with the help of mnemonic instructions. So first we have to do temp1 equals ID3 star 30.0. So first we need to move ID3 into one register. Okay. So move F ID3, comma, register R2. Okay, we may consider R1 and R2, two registers for calculating, for doing these calculations. Okay, so here F represents, we are dealing with the floating point operations, and this is called opcode. It is followed by two operands. Okay, one is source, another one is destination. So what is the meaning here? ID3 is moved into register 2. Okay, then we have to multiply 30.0 with the content stored at R2, right? 30.0 must be multiplied with R3. So for that, we need to write the opcode mul f. Mul f. 30.0, it's a constant. So we need to write with the hash 30.0. It indicates the constant 30.0 is multiplied with the content stored in register R2. Okay, so we have done this, and this is stored into temp1. The meaning is R2 contains ID3 star 30.0. There is no need to move it into temp1. Okay, R2 contains the first statement result. Okay, now we need to move ID2 into register 1. So move F ID2, comma, R1. So now R1 contains ID2. Okay, then this ID2 or R1, content of R1 must be added with the temp1. Temp1 means R2, right? So add F R2, comma, R1. So what is R2? R2 contains the temp1 result, ID3 star 30. That will be added with R1. So the R1 now contains ID2 plus ID3 into 30.0. Okay. Finally, the result must be moved into ID 1. Okay. The entire result is now stored in R1. So move F R1 comma R1 comma ID 1. Okay. So this is the um, assembly code generated for the given example. Okay. So initially we have given with the example x equal to y plus z star 30. Lexical analyzer phase will convert the given input into tokens. Then syntax analyzer will construct the syntax tree, and at the same time it will check the syntax. Then semantic analyzer will do this type checking. Intermediate code generator will produce the three address code. Code optimizer will improve the intermediate code. Then code generator phase will produce the target assembly code. Okay. So these are the 6 phases of the compiler. So by using the 6 phases, compiler will convert the given source program into target assembly program. Thank you.